Good evening. So last class we have seen demand forecasting, right? So we have seen how the quantitative and qualitative methods of how to forecast a demand and the various types of problems for the same, right? I've given you two problems to try out at home. You've got it right. There's no question there. It's the same problems which you have done in class. So okay, so if you're finished, now today we will look at capacity planning. Right. So as we have discussed demand forecasting, so once we get a demand forecast or we get an estimate of what our demand is going to be, so then we know that how many goods or services we have to make for the demand. So for that we have to for manufacturing of those goods and services, we have to have a capacity plan, right? So what is capacity? So what is capacity? Can you try defining? You can use your own words, no issue. Correct, correct. So capacity is nothing but, the maximum amount of goods or services you can produce, right? That is capacity. So goods and services, so to be specific, capacity is nothing but the maximum amount of goods and service that can be produced by one unit or one industrial unit, you can say, right? Okay, so what is an industrial unit? So one industrial unit, it can be a plant. Okay, it can be part of a plant. So if the whole plant is say you're producing say some kind of a mobile, right? So if you're producing a mobile and you have several parts. So you have assembly, you might have software installation, and so if this is a plant, you know so each one will have its individual capacity. So the plant can have a capacity of producing of 100 mobiles per day. Okay, 100 mobiles per day, right? But so that doesn't mean everything else has the same capacity. So assembly can, they probably can do 500 mobiles assembly. Like software installation can probably do 200 mobiles, right? So the plant, so this has an individual capacity, this has an individual capacity, and your separate units have individual capacity. So while looking, but as a whole, the plant has 100 units of mobile capacity per day. So this is what is called capacity. Capacity is the maximum number of goods and services that we can produce, right? Okay. So why is capacity planning required, right? So why should we do this? First simple reason is to meet the demand, right? To meet the demand. You have to meet the demand. Next, so you have you need to for cost of production, so for estimation of cost of production. Now what is this cost of production? So in every production there's something called fixed cost and variable cost, right? So one plant might have a fixed cost, right? There'll be a fixed cost. Now, suppose for this plant you have a fixed cost of say rent. So this is a rented premises. You have to pay rent for this plant. That might be a 10,000 rupees per month, right? Now, capacity, if you do not know, then how can you estimate the cost of production? Now, if you have a capacity of say 100, then you can know that okay, the rent overhead on one mobile will be 10,000 by 100. So it will be 100 rupees, right? So 100 rupees is the rent overhead that is falling on my mobile. So to estimate your fixed cost and the distribution of fixed cost, you need your capacity planning, right? Next, for investment decisions, right? So if suppose your current capacity of your plant is not meeting the demand, so you should know whether you have to enhance the capacity of your plant, right? So for investment decisions, you have to have the capacity planning, right? And for scheduling and for job scheduling and all of that thing, we will need to have capacity planning. Okay. Okay. Yeah. Yeah, yeah, sure. Okay, how do we measure the capacity? So measurement of capacity. So capacity can be, measured in units per hour, or it can be measured in units per square feet. It depends on for what purpose you are measuring the capacity, right? So if if you want to see how many units you want to manufacture per day, then it makes sense if you measure the unit per hour. And now if you want to there's some bricks, if you are making a brick, so it's kind of a clean. So that'll be, you can make a certain amount of bricks per square feet, right? So that will be the output, per unit. So the output of your process with the relevant unit, right? Okay. So now let us see at a few factors determining plant capacity. Okay. Determining plant capacity. So we have discussed, so the investment available, the product mix, or the process, techno tech technology that is being used, and as we have seen already, the demand. Yeah, and so technology, you can have obsolescence also. Okay, so what are the factors affecting your plant capacity, right? So if you have, it depends on the budget you have available. So if you have more money, you can build a very advanced capacity. You can have probably automation. You can have robotic units and robotic manufacturing and all of that. So the investment will affect your capacity, and the product mix and the process. So suppose this, we can take a look at an example. So if you have one factory, right, and you have three products, say A, B, and C, right? Now A takes 5 hours to manufacture, B takes 4 hours, and C takes 3 hours to manufacture. Right. Now, the plant capacity will depend on how many of these are manufacturing. Right. Okay. Now, say, suppose I have, I can work for 16 hours a day. So, if I take 16 hours a day, I can manufacture 4 Bs. Right. Or if I want, you know, I can manufacture 1A and 2 Bs. That's it, right? And 1C. Right. So your product mix and demand of each of the product, that will also affect the capacity of your plant. Okay. And the technology, obviously. So the technology which you use, that also will determine the plant capacity. Now if you are using a very outdated technology, and now we have very advanced technology and very advanced machinery which has come in, but if you're using outdated technology, it will definitely reduce your capacity, right? So yeah. And the demand obviously, you want to match your input with the output. So suppose if you want to sell 100 units, there's no point of manufacturing 500 units, right? If even your plant has a capacity of 500 units, you do not want to do that, because you're just carrying the stock, right? So all of these factors, determine the plant capacity. Excuse me. Okay, coming to capacity, we have some point. Yeah, capacity planning. You have two types: long term and short term. Right. So what does long-term capacity planning affect? So when you look at long-term capacity planning, you will look at the demand in the long term. So you will look at investments, you will look at your expansion plans. Right. So your expansion, your investment decisions. You will, look at your product mix. So if you have these objectives in mind, then long-term capacity planning should be looked at. Okay, so if you are manufacturing a product A, and today your capacity is like 100 units per day. Okay, so the long-term capacity plan, you say you need 1,000 units a day. Your product is, you want to boost it is a growing product. Then obviously you will have to look at expansion. So at the long term, you have to see how you have to expand your plant capacity. Right. So short-term capacity is nothing but this is allocation of job cycles. Allocation of job cycles to your workers. Based on short-term capacity, your working capital management. Right. And overtimes. So if in 1 month you have to deliver 1,000 goods, okay, and you are manufacturing at a slow pace, like say 20 goods or something, then obviously you have to look at how much overtime you have to put in and how much additional load you have to give on your plant. So based on these objectives, so you'll have to look at your short-term planning, right? So these are the two types of capacity plannings. Right. Okay. So now let us look at two terms: plant capacity and effective capacity. So as we have already seen, plant capacity is nothing but the maximum. So this is the maximum capacity available. Right. And effective capacity, this is nothing but, we can say this is a reasonable or or agreed upon capacity, right? We can take a simple example. So plant capacity, now if you say, now you are a student, you are preparing for ICW exam, you are preparing for the CMA exam, right? Now if I say you have 24 hours in a day, you study for 24 hours in a day, that is not right, right? Because we cannot do 24 hours a day same thing. So you will have to sleep for 8 hours. You will have to, 2 hours you have to give for eating your food, and you have to give, say, 1 hour for exercise. You have to give 2 hours for spending time with your family, right? So you cannot say that 24 hours is my plant capacity and 24 hours I will have to study, right? That is the maximum available capacity. Okay. So in the same way, we can see a plant, if it operates for, say, 24 hours a day, it can probably produce 50,000 units a day, right? But 24 hours a day, you cannot have the plant running, because it will lead to your maintenance issues. It will lead to wear and tear. It will lead to work down. So you have to give some time for the plant also to cool down. So this will be your maximum capacity. But what is effective capacity? So this is a reasonable capacity. So if you are 24 hours a day, you can say effectively you have 10 hours a day, right? So if you're saying, you're going to study 2 hours a day, so you are studying for, say, 2 by 10, that is, 20%. 20% of your effective capacity you have to study. So, but if you say the same 2 by 24, so this is the utilization with your maximum, right? This is 1 by 12. So this is the difference between your plant capacity and effective capacity, right? So this is an agreed upon capacity. So because this is your maximum capacity, but the management will not ask you to produce 50,000. So everywhere we'll have, put some rules, and then they would say, okay, so your effective capacity is, 30,000 units per day. So if you're going below this, then you are underutilizing. Okay, so the comparison will be with respect to 30,000 units, right? Okay. Coming to optimum plant capacity. Okay, so if you take a look at, your cost of production, okay, so this we can say your cost of production, and this you can say as a volume output. Yeah. So if you take a look at, your cost of production with your volume, we can observe that, as your volume increases, your cost increases, and at a certain level, you will reach an optimum cost, right? So this point is called your economies of scale. So this is your ideal capacity, so your effective capacity. So, see, when you're producing your goods will have variable cost plus fixed cost, right? So fixed cost will be distributed by the number of units. It will be distributed over your output, right? So this cost which we are saying, this is the, we can say this is the fixed cost. So as at a certain level, you will be producing at your maximum efficiency. The cost per good will be the best at this point, right? And this is called economies of scale. And because why you'll have this at the optimum cost, because you can have many reasons. At this level, you could purchase your raw materials at a bulk, where you might get a discount, right? You can get at a discounted rate. And this is your, ideal plant efficiency. And this might be the number of hours the labor is working where there is job contention for them, right? So all these reasons, and you will have your cost at an optimum at that level. But once if you increase your volume further, if you increase your your volume further, then again your cost will rise. So why will this happen? Because now, because you are putting more pressure, so this cost increase is due to you're putting more pressure on your workers, and they have less morale because of high work, and you have to pay them overtime, right? Because you're asking them to extend beyond their time, you have to pay them overtime, and you will have issues, you will have congestion in raw materials, and in distribution. So all of these factors, it will lead you for increased cost. So this part, after a certain level, it is called diseconomics of scale. So there should always be an effort, to maintain it at a level. See, beyond this, your fixed cost is also rising, right? So beyond this, your fixed cost is also rising. So if your output rising and your fixed cost is rising, the distribution, your cost per product is not being efficiently, it is not effective, right? So because of that, you are actually again deviating from your cost. Your cost is going up. So so this is this portion, this is your optimum plant capacity. So you have to balance your production in the optimum plant capacity, right? Okay. Let us take a look at a few problems. Right. You can look at illustration 5, page number 37. Yeah. So here he says a department works on 8-hour shifts, 250 days a year, and has the usage data of a machine is given below. Okay. So you have one machine and it produces 3 products. Okay. X, Y, and Z. Okay. And the annual demand for each product is, for X is 300 units, Y is 400 units, and Z is 500 units. Okay. And he says the processing time for each of the products is given. So this is processing time in hours, right? And this takes 4 hours, 6 hours, and 3 hours. This is processing time per unit. Okay. Okay. So he asks us determine the number of machines required. Okay. So so to determine the number of machines required, we have to see how many hours of work we have and how many hours are available to us, right? So we can calculate the total processing time. Okay, this would be 1200 hours and 2400, 1500. This comes up to 5100 hours. So we have 5100 hours This is the demand hours, and we have an available hours. So what does he say? He says 8 hours, 250 years. Sorry, 250 days. So 250 days into 8 hours will give you 2000 hours, right? Yeah. So you have a 5100 hours required for realizing this demand, and you have this is for one machine, right? So number of machines required will be 5100 by 2000. That will come to 2 point something, right? $2.55. So we cannot have a machine in fractions, so we will have to round it to 3 machines. So if you have 3 machines, then we'll have about 6000 hours, so we can realize this demand, right? Okay. We'll look at the next problem. Okay, so illustration 6, it says a steel plant has a design capacity of 50,000 tons of steel per day. So this is the design capacity. So design capacity means design capacity is 50,000. So this is like 24 hours a day, right? This is the maximum capacity. Okay. Effective capacity of 40,000 per day and an actual of 36,000. Okay. So he says effective capacity, or which is the agreed upon capacity, is 40,000 units per day. Okay. And the actual output is 36,000 per day. Right. He says compute the efficiency of the plant and its utilization. Yeah. Okay. So efficiency of the plant. So as we have discussed, efficiency is nothing but your actual by your agreed upon or effective capacity. As a percentage, it is into 100. So this is the efficiency of the plant. So efficiency you will always calculate with respect to effective capacity, right? So this will be 36,000 to 100. So that will come to 90%. Is it? Yeah. Right. Efficiency and utilization. So utilization is always calculated with the actual capacity or the design capacity. So utilization will be your actual by design or maximum capacity as a percentage into 100, right? So that would be 36,000 by 50,000 into 100, 72%. Okay, any doubts? Let's move on to the next problem. he says a firm has 4 work centers, A, B, C, and D, in series with individual capacities in units per day. Okay. So, as we saw an example earlier, so you have a plant, maybe a mobile manufacturing plant, okay, and in this you have 4 divisions. So you have A, B, C, and D. Okay. So he says, so raw material comes from A. So raw material from A. So the work will flow from A to B, B to C. Let us keep this as C. This is D. B to C and C to D. And you get the output. It flows through 4 processes. So that is 4 work centers, and then you get an output, right? So he has given an individual capacity for each of the work center. Okay. So he says A can do a maximum work of 380 units per day. B can do a 360 units per day. C can do 340 units per day, and D can do 400 units per day. And he says the actual output. So actual output is equal to 300 units per day. Right. Okay. So his question is identify the bottleneck center. Okay. So what is a bottleneck center? A bottleneck center is something, that will limit your efficiency. It will not let your efficiency go beyond a point because that is its maximum capacity. So because it has reached its maximum efficiency, so that is your bottleneck center, right? So suppose you're driving a car and your car goes at a maximum speed of 100 kilometers or 100 kmph, 100 kilometer per hour, yeah. So this is the maximum speed. So this is the bottleneck. So you cannot go beyond this speed because this is your maximum capacity of your vehicle, right? Okay. So now he says identify the bottleneck. So in all of these 4 units, what will be your bottleneck? A, B, C, or D? C, correct, because C can produce maximum 340 units per day, right? So if A gives B 380, so B will also be able to only produce 360, right? So 20 units it will have to hold for the next day, probably, right? So now B gives to C 360 units, it will only process 340. So 20 units it will have to hold for the next day. So because this is the maximum, now C will give to D 400 units, but 340 units, but D has a capacity of 400. So it can push an output of 340 because it has a capacity. So your C is the bottleneck. So because C has reached its maximum efficiency, so you can only produce 340 units a day. So this is your bottleneck. Okay. So in capacity planning also, if you know a demand, a final output demand, and then your next point would be if you have to increase your output. Your next point will be you have to identify the bottleneck, right? So once you identify the bottleneck, then you have to take corrective action at your bottleneck so that it will increase your capacity, right? So if this is a real life scenario and you have to increase your output to 400 units a day, or probably say 350 units a day. So if you have to increase 350 units a day, then what we'll have to do? You have to just concentrate on C. You have to take action at C, and then you just increase this to 350. And then your capacity will automatically, because everything else can process more than 350 a day, except for C. right? So, C is your bottleneck. Now, what is the system capacity? So, system capacity is 340 a day, so which we have already seen. Now, what is the system efficiency? So, we already saw the formula for efficiency. So, efficiency is nothing but actual by effective plant capacity into 100, right? So, actual is 300 divided by 340 into 100, which will come to 88.23%. Okay, any doubts? No, bottleneck center is C. Yeah, both will be same. Let us look at illustration 8. Okay. Any doubts in the previous question? No, right? Yeah. So here he says a manager has to decide about the number of machines to be purchased. He has three options: purchasing 1, 2, or 3 machines. The data is given. Okay. Let us, let us replace the number with the name, otherwise it is confusing. Huh? So let us say there is machine A, B, and C. Okay. He has given annual fixed cost for each of the machine, and he has given the corresponding range output. Okay. So he says machine A has an annual cost of 12,000, B has a cost of 15,000, C has 21,000, right? And this ranges from 0 to 300. This is 301 to 600, and this is 601 to 900. Okay, so these are the corresponding outputs. He says, he also gives information set variable cost is rupees 20 per unit, and revenue is rupees 50 per unit. Okay. The first part of the question is determine the break-even point for each range. Yeah. So what is a break-even point? Anyone? Yes, that is correct. So break-even point is a point where, at what number of units, you have zero profit and zero loss. Okay. So at a particular output level, you will have zero profit and zero loss. So that point is called your break-even point. Okay. So he says calculate the break-even point of each of these machines, A, B, and C. Okay. So let us calculate. Let us calculate for A. So, okay, to calculate the break-even point for any manufacturing, you will have fixed cost plus variable cost, right? So if you take a look at profit will be nothing but your revenue minus cost, correct? So that will be nothing but revenue minus fixed cost plus variable cost, right? This is your total cost, correct? Now we know now what is break-even point. Break-even point is something where the profit is zero, right? So 0 should be equal to revenue minus fixed cost plus variable cost, right? So your revenue should be equal to your fixed cost plus variable cost at break-even point. So at break-even point, your revenue is equal to your fixed cost plus variable cost. Is this clear? We have just replaced profit with zero value, because at break-even there is no profit or no loss. Okay. Okay, so now let us calculate the break-even of A. So A, we know that you have a fixed cost of 12,000, right? And the range is given 0 to 300. Next, yeah, 0 to 300 is the range. Okay. Okay, so let us assume, okay, so let us just write this equation first. Okay, so the revenue, let us do it in a new page. So let us revenue equal to fixed cost plus variable cost. So let us take the number of units at break even is X. Okay, so we know the revenue per unit. Revenue per unit is 50. 50 into X is equal to fixed cost is, so fixed cost is 12,000, variable cost is rupees 20. So 20 into X plus 12,000, right? This will be my equation for break even for A, right? So let us take, so 30X equal to 12,000. So X would be nothing but 12,000 by 30, 400. 400 units, correct? Now if you look at the range of A, it is 0 to 300. So if I buy this, I don't need to look at the output at all. So it is 0 to 300 and the break even itself is at 400. So I will not, because it doesn't make any sense, because I cannot even reach my break even. If I manufacture at 300 also, it will be, I'll be at a loss. So it will be 15,000 and this will be, sorry, 6,000. It's 18,000 already at 300 and my revenue is only 15,000. So I'll be a loss at 3,000, right? Okay. So this is the break even of A. So break even of A is 400 units. Similarly, let us calculate the same thing for B. So this is A. For B, it will be the same. 50X is equal to 20X. So nothing will change. Variable cost will remain the same and revenue will remain the same. Only your fixed cost will change. So at fixed cost is 15,000 rupees. Right. So same, let us 30X equal to 15,000 and X would be equal to 200 units, right? 200 units. Did I make any mistake? Sorry, 500 units. Yeah, this is 500 units. So break even of B is 500 units. Okay. Let us similarly calculate for C. I'll just do it here. So for C, again it would be the same. 50X equal to 20X plus 21,000. fixed cost of C is 21,000. Okay. So you will get 30x equal to 21,000. X is equal to 700 units, right? So break even of C is 700 units. Okay. Any doubt in this? Yeah. Okay. So that was your A part of the question. Excuse me. Okay. So the second part he asks, if projected demand is between 600 and 650 units, how many machines should the manager purchase? Okay. So we have a break even of each machine. He says projected demand. So he says the demand is between 600 to 650 units. How many machines should the manager purchase? Okay. So it means which machine he should purchase, A, B or C. Right. So we have seen the break even of A is 300 units. Sorry, break even of A is 400 units. Is 400 units. Break even of B was 500 units. And break even of C was 700 units. Right. And we also had the range. This is 0 to 300. So it cannot give an output beyond 300. Okay. This is 300 to 600. And this is 601 to 900. Okay. Yeah. So now 600 to 650 units is the demand, right? So I cannot go with C because I will not be reaching my break even, right? So C is out of the question. And I cannot go with A, although the units are more than my break even, my machine cannot deliver more than it cannot deliver the asked number of units, right? So because I cannot get 600 units with, machine A, okay, so I cannot go with A. So the only option which we are left is with B. So with B, you can, it is profitable because your break even is at 500. So anything above your break even will deliver you profit, right? Anything below your break even will give you a loss, correct? So because the demand is greater than my break even, so we will go with machine B. Is this clear? Any question? Okay. So let us stop here for today. Next class we will look into facility, location and layout. If you have any question, you can ask. Otherwise we can close.